Last video going through indirect truth tables for the fundamental forms. So again, we've laid out the valid forms and invalid forms for mixed hypothetical syllogism. Now I'm just going to go through a quick indirect truth table for each one, showing why and proving that they are either valid or invalid in each case. So the valid forms, we have the two valid forms known by their Latin names, modus ponens, modus tollens, and then the two invalid forms for mixed hypothetical syllogisms. And these are the names of their corresponding fallacy that's committed, denying the antecedent, affirming the consequent. So let's go ahead and do the indirect truth tables for those. Start by highlighting the main operator or the column that we're going to be looking for each statement. True, true, false. Again, we're looking for a line that proves the argument invalid, which would be a line where all premises are true and the conclusion is false. This one's pretty intuitive. We already have the statement variables filled in. So let's just carry over the truth value. True for P, false for Q. And looking at this first statement, we have a true antecedent, false consequent. That is the one case where a conditional is false. And it says that it's true. So already we have a contradiction. So since we're unable to fill in a line where all premises are true and the conclusion is false, it's got to be valid. So moving on to modus tollens. Highlight the correct column. True, true, false. We've got negations here, so let's fill in true for P, false for Q. We'll carry over those truth values, so we have true for P, false for Q, and again, we have a true antecedent, false consequent. That's the one condition where the conditional is false. It says that it's true. So we have a contradiction right there. So again, since we're unable to fill out the line that we're looking for, the argument's valid. Moving on to the invalid forms. Same thing. Let's highlight column. We have true, true, false. We have two negations. Let's fill these in. False for P, true for Q. So let's carry those over here. False for P, true for Q. So this conditional, we filled in these lines. Looking at this conditional, we have a false antecedent, true consequent. It's going to be a true conditional, so we have no contradiction. We're able to fill in that line that proves that the argument is invalid. Last one, last invalid form. The fallacy that's committed is affirming the consequent. So let's go ahead and highlight those. True, true, false. Conclusion. So we have Q is true, false for P. We have a false antecedent, true consequent, which results in a true conditional. So we have no contradiction there. And if anytime you are able to fill in a line without any contradictions that has all true premises, the false conclusion proves that the argument is invalid.